right, so I'll just start the tally now.
I'll just start the tally.
What? Yeah, I have one down here. Why? I'm not technically allowed to. They frown upon that. All right, so this is the second half of 4-5. Example 3 has horizontal transitions. So these first two that we did here, well, this first one had just one horizontal transition. We moved to the left pi. And then this one, we moved to the left pi, but we also had an amplitude change of 2, right? So on this one, a little fuzzy. See if I can unfuzz it. Apparently not. Beep. One more click. Oh, that didn't help, did it? Well, to heck with it. I'm not in the mood today, right? Is that better or worse? Yeah, we'll go with it. All right. Oh, gosh, now I'm getting hot. All right. So then let's look to see what we have here. What's our amplitude? Yeah, what's in front of the sign? 1/2. Bless you. So that means it vertically shrinks it, right? Squishes it down vertically. And then our period, has our period been affected? Nothing in front of the x, so it's still 2 pi. And then, do we have a vertical shift? Is there anything outside here being added or subtracted? No, so that would be none. Horizontal shift. What? Pi over 3. What direction? Because it's negative, we're going to go to the right. So we are going to go right, pi over 3. So that means we need to count by pi over 3s, right? Correct? So our key points are going to change. And so let's look at how we're going to change those. So our normal key point, our first key point is 0, right? It would be helpful if I were even looking at the correct notes. So our period hasn't changed. It's, our normal period is going to go 2 pi divided by 4, which is pi over 2, correct? However, and I guess you could do it, well, I still wouldn't. Here's what I would do. I would do 0 plus your pi over 3. Because that 0 is going to move to the right pi over 3.
How do you know how to change it to
Say that again.
How do you know how you're going to change the number based on what changes so that
My key point?
Yeah.
Well, it's easiest to see from 0 when you're moving right and left. And so if this is 0 and I'm moving it to the right pi over 3, that point there at 0 and that sign, so wouldn't it be up here at 1? Or 0? Which is it? 1 or 0?
1.
Look at your sign code. 0.
0. Sorry.
All right, so my point is at 0, 0 for sign, right? And then if I move it to the right, that normal point is normally at 0, 0. If I move it to the right pi over 3, won't it move to pi over 3? That's why I start with 0. Because it's the easiest one to see where my starting point should be. But because my period has not changed, and every hash mark in my period has to go by pi over 2, right? So I could take each of the normal key points. So if you look over here, remember these normal key points here? I could take each of these and add pi over 3 to them, because essentially I'm moving each one of them pi over 3. So that's one option that you could do.
So are you changing it based off of the normal people?
Yes. I'm always looking at, those are my starting points, so to speak. And so all of those, I could add pi over 3 to. Or I could take my first starting point here, which I now know it starts at pi over 3, right? So this is my first starting point. And then from there, I could add just pi over 2, because it should go every pi over 2, because I have a period of 2 pi, right? So I would choose to add, instead, this time, pi over 2. I mean, you can do it either way, it doesn't matter.
Where are you getting the pi over 2?
Because my period is 2 pi, right? So I'm going to take that, if I divide that by 4, I should be counting by half pi's, right? So if that's my first starting point, I'm going to add a half a pi to that. As I said, you could just back off and just add pi over 3 to each of your original key points. That's one option. This is a second option. But I can't add these with the unlike denominators, right? So what denominator should I have? 6. So this needs to be changed to times 2 times 2, and this is times 3 times 3, right? So now I really have 2 pi over 6 plus 3 pi over 6.
Will you guys have room on the test?
Uh-huh. Yeah, definitely. So that gives me how many pi's over 6? Yep. So that gives me 5 pi over 6. So there's my second key point. Then I'm going to add to that a half a pi. Well, don't we know that the half a pi is pi over 2 is 3 pi over 6? So I'm just going to add 3 pi over 6. Sorry, I'm losing my voice. So now I have 8 pi over 6, right? And if I were you, I would probably leave it in 1/6 of a pi. Why? It's kind of easier to count that way, isn't it? I mean, technically the answer is 4 pi over 3, isn't it? This is my third point, or 4 pi over 3. But I don't want to keep switching it because I want to keep it in 1/6. And then add another 3 pi over 2. Or, sorry, 3 pi over 6. And I get 11 pi over 6. That one doesn't reduce. And then finally, one more, 3 pi over 6. And what do I get? 14 pi over 6, which reduces to what? Technically, it's 7 pi over 3, right?
But you won't hurt yourself if you don't reduce it.
Well, watch what I'm going to do. Because you already know what your key points are going to say, right? And we're just going to split this into, here's my starting point. 1, 2, 3, 4. I have to have 5 points, right? This first point is pi over 3, right? And then just for my own sake, I'm going to label every point. So this is pi over 3. The next one is 5 pi over 6. The next one, I guess technically I should label as 4 pi over 3 because that's the proper form. And then I had 11 pi over 6. And then finally we had 7 pi over 3 because that's what 14 pi over 6 reduced to. So now I really don't have to worry about them anymore, right? These are where my key points are going to be. So the only change I have is I've moved everything. So this original point here got moved right here. The only other thing I have to watch out for is my amplitude, right? So for sine, it starts at 0. Oh, and then I have to do my vertical, right? So here's 1, here's a half, here's -1. So how high am I going up? Because every hash mark I'm going to go up, right? So, but this time I'm only going up a half because that's what my amplitude is. The next hash mark I go back down to 0. Then the next hash mark I'm down below at -0.5, right? And I go back up to 0. So this is my new sine curve. So the key points can be a bit of a pain in the patootsies, right? Be your derriere or your rear end. All equally acceptable terms.
Do we have to draw like the original or the...
You could have if you wanted to. I'm trying to get away from that right now unless it really makes you happy. We can still do that, and some things you'll still see me doing it because I'm a visual person myself. It helps me if I look at the original and then move that. But some things like this one, it was easier just to start from here. That, especially when it's weird fractions. All right, so look at the second one. What's different about this one? A couple things are different. Lots of things are different. What's our amplitude this time? Yeah, but it's negative. So the amplitude's not -3, it's 3. What does the negative do? What does it do? It reflects it, remember? So you are going to see me probably drawing the original. We'll talk about it. But the amplitude is really 3. Don't tell me it's -3. The amplitude is 3, but it has a reflection. That's a L. So you might want to write yourself a note here. Reflection down. Or technically across the x-axis. And then because it's cosine, remember the cosine curve looks, at least the period part of it, looks like the Gaussian model, right? Or an upside down bell curve. Well, that means that this time it's going to be right side up bell curve, right? So that you're kind of expecting to see what it's going to look like. Is our period changed? What's in front of the x? Yeah. So we do have a change in our period. That's our b.
That's the same thing. That's the idea.
As what?
It's the last one is 2 pi.
The one before this, no, but the one before this didn't have anything in front of pi. What this is, it is the same as our period. So this is what we do. We take our normal period of 2 pi, but we're going to divide it by b. Remember on the very front of this page, we take this, whatever this happens to be, and I want you to understand I'm not dividing by b. That is b. And I'm going to divide this by 2 pi because that's b. What do we end up getting? So this time our period is 1. Just 1. And then that's going to affect our key points, right? Mike, are you writing any of this down? Okay, you look like you're taking a break. All right, is there any vertical shift? Thankfully, no, we have enough going on, right? So there's none for that. What about horizontal? Okay, so the horizontal is 4 pi to the right or the left? Left, 4 pi. And they didn't leave us a whole lot of room over here. So we're going to have to somewhat squeeze it in a little bit. And then let's look at our key points. So to get our key points, we need to take our period of 1 and divide it by 4. That means I'm counting by fourths this time. I'm starting, I have to figure out what my starting point is. So remember in example 3 up here, we did the start and the finish. Did we take what was in parentheses and set it equal to 0? That was our start. And we took what was in parentheses and set it equal to 2 pi because that was our finish. But that was our normal period, right? Well, this time, we're going to do the same thing. Whoops, let me move this out of the way. Okay, so this time we're going to take our start. Take what's in parentheses, 2 pi x plus 4 pi, and set it equal to your normal start, which is 0. We need to solve for x. What do we do first? Subtract 4 pi, so we get 2 pi x equals a negative 4 pi. Because we expect to get negative, right? So that makes sense. And then what are you going to do? Divide by 2 pi. You get x is equal to, won't the pi's cancel? What's negative 4 divided by 2? Negative 2. So our point at 0 is going to move all the way to negative 2. Our end, or our finish, we're going to take the 2 pi x plus 4 pi and set it equal to, where do we normally finish? 2 pi, right? That's our normal finish, usually is at 2 pi. So solve for x. What do you do first? Subtract 2 pi. What's 2 pi minus 4 pi? Negative 2 pi. Then to solve for x, what's negative 2 pi divided by 2 pi? Negative 1. So we're going to start at negative 2 and end at negative 1, and we're going to count by fourths in between. Let's see how that works. Yes. Can that be done? How far apart is negative 2 and negative 1? How far apart is this? On the number, 1 unit apart. What's our period? 1 unit. So we can count by quarters, right? That's why so we ended up with a period of 1 unit, which is what we wanted. So really our entire graph is over here, isn't it? So if I were you, I would break this into fourths. 1, 2, 3, here's your fourth. You might have to extend your line a smidgy if you want to. So I really need to have 5 points, don't I? I'll need one more. So if this is 0, this is -1/4, -1/2. Oh wait, I wanted to start at 1, huh? I really have to extend it a lot. 1/4, 1/2, 3/4. This is -1, isn't it? Oops, I'm going to go into my other one. So sorry. And then -1/4, -1.5. -1 3/4, and then here's my -2. Can I do what? Zoom in. I don't know why it's fuzzy today. It's just not cooperating. I'll zoom in one more. One more. Oh, there we go. Whew. Problem is I have so much work to show, it won't show it all. All right, we ready to figure out our key points yet? Okay, so what is our start point? What's our start point? -2. So -2 is going to be our first point, right? Oh, you can't see that. Let me move over. So -2 is our first point. What's -2 to the right a quarter? What's this one right here? We'll add a 1/4 to that. What do you have? What's 2 minus a 4th? Yeah, because they're opposite signs, right? A -2 and a positive 1/4, so we're subtracting. What's 2 minus a quarter? 1 3/4, so it's -1 3/4. Right? What's 1 3/4 minus a quarter? -1.5. Yes. No, I would. Decimals are so much longer on the number line. What's 1.5 minus a quarter? -1 1/4. And then what's, 1/4? My hands are not cooperating with my mouth. And then what's 1 1/4 minus a quarter? Did we end up where we wanted to? Do we have 5 points? Then we must be okay. It's kind of how you can check yourself. All right, so we've moved everything, right? We know what our key points are. We have an amplitude of 3. So wherever there was a 1, we'd be at a 3, right? Or a -3. And wherever there's a 0, we'll stay at 0. But we have to reflect. So our original would have gone this way, like down here like this, wouldn't it? We have to make our, here, there's 1, 2, and 3. This is -1, -2, and -3. So, at our first point, on the cosine, for our very first point, very leftmost point, do we start at 0 or 1 normally? We normally start at 1. But because of the amplitude, we're going to go up to 3, correct? But, aren't we reflecting it? So we're going to go down to -3. So, here's the first point right down there. Yeah, we're doing 2 things at once. 3 things technically, right? So at the next point, don't we go up to 0? The next one's at 0, right? And then there's no amplitude change because 0 times 3 is still 0. And then there's no reflection if you're on the x-axis already. So this one actually stays right here. Then the next point, where should it go? Because by this time we should start to know what the curve looks like. Shouldn't it go up to 3? If you don't believe me, look at this. The original point would have been here at 1, but then we would have gone up to 3, right? There's the original point. Then we would have gone to 0. Then it should go down below to 3, back up to 0. And at -1, we'd be back up to 3. So wouldn't this be our normal curve before it's reflected, very lightly.
So it's just,
All I'm doing is flipping every single point. So this point got flipped here, this point stays. This point got flipped up to here, this point stays. This point gets flipped down to here, doesn't it? Here's -3. I've lost Matt. Matt's like, oh, good Lord howdy. So then this is our actual curve. Oops, I missed there. That's my actual curve. This one is hard. This one is hard. It is hard.
would this question be on?
Yes, it would be. I'm sorry to say.
Well, this test
So sorry to say, but we're going to practice.
is the next thing I'm doing a test on
A test.
those.
Super. Correct, no notes. Super duper. All right.
I vote we should have taken this whole section as a.
Oh, you should hope. You're lucky. I'm the only teacher who lets kids use their notes on their quiz.
Yeah,
You should be thankful. Okay.
No, yeah, why do you do, not like.
Because I want to encourage you to take good notes, and I feel there should be a reason for you to take notes, so why not? Plus, honestly, it doesn't really help kids all that much. You gotta know what the notes are doing.
Honestly.
And quizzes aren't worth as much as the
study for
tests.
The actual test.
See, there you go. Thank you.
Like, because then I actually know what I'm doing.
Yep. It releases some of the tension because you're not quite ready to take a test on it because you're taking a quiz. You're just kind of seeing where's your knowledge. Where the test is, have you mastered it? That's my opinion as a teacher. Okay, so let's look at 4. 4 looks a lot less intimidating, doesn't it? There's no parentheses this time. So what does that -4 mean? Now that's a vertical translation, right? Up or down? Down, because outside the parentheses, it's the same sign. So what is our amplitude? 1. How nice, right? What is our period? 2 pi, because there's nothing in front of the x. Vertical. What did we just say? Down 4, right? Horizontal? None. And our key points. Have those changed? Since there's no horizontal shift, the key points are the same. That's the nice thing. As far as for the x value. The y value's changed because we have a vertical drop, right? So our key points start at what? 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, so let's partition this out. Because I'm going to drop, and technically when we have a vertical drop, we're going to drop that x-axis down 4. So and then on top of that, our amplitude is 1. So I have to have at least 5 hash marks down here because I have to go down an additional 1 because of how my curve goes. I'm only going to go up to 2 on the positive vertical axis only because I'm not going to need it. So do you remember when we were drawing what you might consider now the easy curves and we had vertical and horizontal asymptotes? Remember how I made you move the asymptotes and put in the dotted line and that would help you determine the shape of your curve, right? We're going to do the same thing. Because we have a vertical drop, we're going to move the horizontal line down 4. So I moved it down 4. I'm going to put in a dotted horizontal line. So that's y equals -4. And that way, because you already know the pattern to the curve, don't you? You know, for sine, we start at 0, right? And don't we go up 1, back to 0, down 1, back to 0, and done? right? We're just gonna do the same thing, but off of the green line. So we don't have to worry about where it goes, because our amplitude is 1. So at the next hash mark here, I'm gonna just go up 1. At the next hash mark here, I'm gonna go back to 0. The next hash mark, I'm gonna go down 1. And the last hash mark, I'm back to 0. So my curve is here. Painless, right? That wasn't so bad. Are you okay, Matt?
Remember that you was making stuff up this
Me?
Yeah,
I just make it up?
yeah.
Make what up?
This
Does-
cannot be real. This is unbelievably difficult, and it's not useful for real life.
But this
Right?
is much
It's
easier than the last problem we did, wouldn't you agree?
Yeah,
Okay.
yeah, that is really
Wait,
good.
yeah, it's not, this is.
Did I not, no, don't you even start there. Did I not warn you? Oh, you were gonna do some application problems, don't you worry. Oh, yes, don't you worry. Deep breath, in through your nose, out through your mouth. I warned you it was gonna be tough on your brain, okay? We will get through it. We will get through it. Okay, look at the next one. I'm trying to break it into pieces for you, right? Trying to break it into pieces. You tell me what's going on in the next one.
We're adding things that we don't need to add.
Thank you, Michael. Okay, let's start with the amplitude then. What's the amplitude of this one? Very good, 3. No reflection, thank goodness, right? Now, what's the period? Oh, no, it's not. Okay, the normal period is what? 2 pi. What's in front of x? 2. I have to take that 2 and I have to divide it into my normal period. So what's in front of x doesn't tell you what your period is. You use it to divide into 2 pi. So you're right. The period is now pi. So that means our key points are going to be affected. Okay? We'll get to those in a minute. But our distance from the first key point to the last key point will only be a distance, a width of pi.
When and when not, like, and when will the key points not be changed, when will they change?
The key points? Key points will change if your period changes. Key points will change if you have a horizontal shift, which we don't here, thank goodness. So we don't have, because the other one we had both things going on, right? All right, so then do we have a vertical change? Yeah, this time this is in front, right? So write yourself a note. Oh, you didn't tell me you couldn't see all that. Write yourself a note that this is really D. And it can go either in the front or back. They like to switch it up on you because they wanted you to think that that was the amplitude. Isn't that nice of them to try to confuse you when you're already confused? Uh-huh. All right, so vertical shift we do. Are we going up or down 2? Up 2. You too. Yay. Horizontal. Oh, that's my funny math joke. Any horizontal change?
No.
None. All right, now let's concentrate on our key points. This is easy. Take your period. What's your period? Pi. Divide it always by 4. So that means we're going to count by pi over 4. Since we had no horizontal shift, since we had no horizontal shift, that means that we're going to start with 0. Okay? So 0 is my first key point. Still is. Then I'm going to add to that pi over 4. What do I get? Pi over 4 is my next key point. Then I'm going to add to that pi over 4. What do I get? Oh, you didn't tell me you can see it. Then I get, yeah, pi over 2. 2 pi over 4, right? Which is pi over 2. Then I'm going to add to pi over 2, because that's only 3, pi over 4. So what's 1/2 plus 1/4? Yep, 3 pi over 4. That's my fourth, one more. And then I add to that pi over 4. What do I get? Pi. Did I not say that the distance between the first and the last point would be pi? Right? The distance between your first key point and your last key point should be your period. Period. Oh, you don't think I'm funny anymore. Okay, so then let's go ahead and count that out. So 1, 2, 3, 4. But this time I'm counting by fourths. So this is pi over 2, and this is pi. Negative pi over 2. And then my amplitude is 3, so I need to go up 1. But I'm going up 2, right? So if my amplitude is 3 and I'm going up 2, don't I have to really have 5 hash marks up here? So 1, 2, 3, 4, 5. So 2, 4, negative 2. Because I had a vertical shift, what do I want to make sure I add in there? Here's my y-axis. I want to shift it up 2. Hello, Mrs. Strand. So this is y equals 2. It might be a while. What would you like? Go in that file cabinet touching the wall and the third drawer down. I just put all the new stuff in there.
Thank you.
You are welcome. Yeah, start with 8-1. And you might want, take that exponent rule sheet too. I'm gonna give that to the kids.
Okay, thank you.
Uh-huh. And then there's also that quiz in front you might want to give at some point. All right. I know, it's all on the video. All right, so what's the shape of the cosine? What does it look like? It's the upside down bell curve, right? So where do you start at 0? Is it 0 or 1? Cosine's a 1, right? Okay. So instead of 1, what's 1 times 2? I'm sorry, 1 times 3. We have to have an amp of 3, right? So don't we have to go up 1, 2, 3? So we're really at 5 here, aren't we? Then the next hash mark, where should we be at? 0, right? Yep, so we're at 2. Because we're using the green line as our new baseline. And then the next hash mark, don't we go down? Normally we'd go down 1, wouldn't we? But how far are we going with an amplitude of 3? Down 3. So 1, 2, 3, that puts us at -1. Did you get everything? Okay, thank you. Yes. Pardon? Oh, hang on. Come over here, Mike. It's over here somewhere. Go out around the other side, otherwise you're on the video. Go that way. I don't have a release for you, so go around. All right, so on the next hash mark, aren't we back up to 0? This is our 0 line. And then at pi, how far up do I go? 1, 2, do I go up to 3? Look on the tabs. It should say 4, 4, 5.
Oh, here.
Is that it right
That's
there?
notes. but
You're still- Keep going.
in the notes?
No, not the notes. No, not that one.
Nope,
One of
nope,
these. One of these.
Oh, it's in here?
Well, no, is that the notes? You
Yeah,
said it
it
was
says
notes.
notes,
No, check. Jeepers. Okay, pardon me,
don't
but
see
Michael
it.
can't find the
It
notes.
says, well, I can't find the notes. It's not.
Hey, it's Michael's shout out. He's shouting out to himself.
Well, maybe it's not here, Mike.
Oh.
Could
so
be me.
Guess I'm good.
No, but I swear. Michael. Okay, Mike, it's not you.
Hey, don't get
I'm not trying to. I'm not trying to get in the way.
Here it is, Michael. Why can't you find it? Have a nice weekend, Mike. Are you leaving? Oh, then wait. Okay. Shh. All right, so let's connect. Let's connect. It should look like an upside down bell. Yes.
On the chart, we have a dot on pi and 6, or is it 5?
It's pi and 5. That's supposed to be 5. All right, are we good? Let's continue.
He's upset.
No, he wasn't, was he?
It sounded like he slammed the door.
No, no, no. Those doors are easy to slam. All right, so let's look at number 5. It's Friday and I've lost you, I can tell.
Oh, you lost me a long time.
I lost you a long time ago. All right, well, you'll like as we go a little further
Oh my
here.
God, is that sign?
No, no, no. Now you get to figure out, wait, you get to figure out your own graph. So you have to plot the following. Are you ready? Plot the following. 1, 2, 3, 4. This is pi. This is 2 pi. And this is negative pi. So just do that. I'm giving you the graph, and you're going to come up with the equation. Okay? Really? Then your vertical axis is going to go 1, 2, negative 1, negative 2. Plot the following points. Plot a point on the 0 at pi over 2. So that point there. Then at pi, I want you to go all the way up to 2. And then at 3 pi over 2, I want you to hit 0. And then at 2 pi, I want you to go down to negative 2. Oh, and then we need another point here. And then you need to put a point here. So this is our next hash mark. This goes out to here. So connect. Right there. Okay? So you should recognize that curve. It's sine, right? So you have to figure out, is there an amplitude? So that would come in front of sine. Is there, what's the distance from here to here? If this is pi over 2, and I'm counting by halves, what's this right here, this last point? 5 pi over 2, right? So figure out, has the period changed? What's 5 pi over 2 minus 1 pi over 2? What's the difference?
4 pi.
4 pi over 2, which reduces to 2 pi. Has the period changed? No, the period's 2 pi. So there should be, the B should be 1, right? B should be 1. Period has not changed. What's the only thing that's changed so far? The amplitude's changed. Are you listening? The amplitude's changed, right? And what else has changed? And there's a horizontal shift. Isn't that the only thing that's changed? Okay. So we're going to write our equation. Because it normally starts at 0. How far did it shift from 0 to the first point? 1/2 pi, right? That's our shift. And it shifted to what direction? Right. So we have y equals, because it's an equation, what was our amplitude? 2. And then what did you say it was? Sine. Because you have to choose sine or cosine. And then because I have a horizontal shift, we're going to use parentheses. We had no change in period, so nothing comes in front of x, right? If our shift was to the right, do I have a plus or a minus? I have a minus is correct. Not 1. How far did I shift? 1/2 pi, so it's pi over 2. And then end parentheses. You just wrote the equation. Let's backtrack again. Shh, backtrack. Stop and listen. Look at the graph. You recognized immediately it was sine, right?
Right.
Check one off, or I figured that one out.
Yeah.
Okay? Yippee. Then, the next thing you want to look for is the amplitude. The easiest way to look for the amplitude is find the 0 line. The 0 line is always the very center, whether or not it's at the x-axis, right? So you can take a ruler just like this and cut it right through the center, okay? How high is it from the center to that highest point up right there? How high did it go?
2.
That means the amplitude is 2. It doesn't matter if there's a vertical shift. The amplitude is still 2. There's not a vertical shift on this one, right? So we knew that A was 2. Then the other thing you noticed is, oh wait, it didn't start here at 0. How far off from 0 is it? 1/2 pi, right? And it moved to the right moving to the right is inside parentheses and opposite sign. So the opposite sign of right would be negative and pi over 2. Little pieces, baby steps, take it a piece at a time. Look at the next one. Danny.
Parentheses, right?
Parentheses, if it's a horizontal shift. If it had been a vertical shift, up or down, there'd be no parentheses. Okay? All right, so look at the next one. So the next one, I want you to put in 1, 2, 3, 4, 5, 6, 7, 8 little hash marks here. So I'm counting by quarter pies. And then do that over here to the left, but only 4. And then I want your vertical scale, you need to have 8 on the vertical scale. Make it tiny. Then you are going to put a point at negative pi over 4. So here is negative pi over 4. You're going to put a point all the way up here at 8. And then at pi over 2, which is right there, you're going to put a point at 4. And then at, oh, you know what, boo-boo.
2.
I did remind you I was sick, right? Oopsie doopsies. We'll just scratch that little one out. We'll make it pi over 4. And we'll put it right there. This is just a smudge. It doesn't exist. Sorry, I just can't read my writing. My bad. So how far apart are those 2 points? How far is negative pi over 4 and positive pi over 4? A half a pi. I'm counting by half a pies. All right, so then go 2 over, so you're now at 3 pi over 4. This is 3 pi over 4. Just remember this one doesn't exist. Oop, it's not there. Put a point at 0. Then count to the right 2. Then where do you think we're going to go? Back up to 4. So you have a vision of what this one is. And then go 2 more over and go all the way up to 8. So it looks like this. I don't do sine curves very well, but there you go. Now, what is this point right here? Count by fourths. 1, 2, 3, 4, 5, 6, 7. This is 7 pi over 4. Okay? So let's find our period. Because we want to make sure it's, that hasn't changed. So our period, we're going to take 7 pi over 4. We want to find the distance between this and our very first point was what? At what? Negative pi over 4. When we find distance, don't we subtract them? Okay? When I subtract these, what do I get? 8 pi over 4 because minus and minus becomes plus plus. 7 plus 1 is 8 pi over 4, which is, hallelujah, 2 pi. The period did not change. Is there something in front of x? Glory. Is there anything in front of x? No, just a 1. That's b, right? If your period had changed, we'd have to adjust b. I'm telling you right now, probably your period won't have changed because that's a tough one. Is there an amplitude? First of all, where's the 0 line? Right here. Isn't this in half? Right there. Wouldn't that be the half?
Yeah.
So put a different colored dotted line right through here because we need to see the amplitude if it's changed. What does that mean then?
I don't know.
Wait. If this is moved up to here, what does that mean? No,
The
up.
vertical.
Vertical shift. So we have a vertical shift of what?
Forward.
Of 4, and it's up 4, right?
Yeah.
So that's a plus 4. So don't we know? Oh, thank you. Don't we know that outside parentheses we have a plus 4? So far we're working with y equals. Let's get our amplitude. What's our amplitude? What's the distance from here to here? 4. This is 4. So our amplitude is 4. You said that it was cosine. And then do I have a horizontal shift? Yes, I do, because normally cosine would start here. How far off is it? 1/4 pi to the left. So a left change is what? Plus pi over 4. See, it's not so bad the second time around, but don't forget your vertical shift of plus 4. Ah, done. Oh my goodness. Okay, now last thing we're going to use our calculator on. Look at the last one. Oh, yippee. That's what you say. All right, so you're going to, it's very important that you take your calculator and put it into radians. If you don't have your calculator in radians, it won't graph the curve. So change your mode. Change your mode. Listen up. Change your mode. And put in y equals, clear out anything that might be there, 4 cosine x plus, find your pi, divided by 4, end parentheses, oh gracious, and plus 4. Isn't that what we just figured out the equation to? In number 5 above?
Oh my gosh.
Oh my goodness, yes. Hit graph.
Maybe not.
Uh-oh, what did I forget to do? That's what you're going to see if you don't have it in radians. So if that happens, just go to mode and go, oh, yep, something was wrong. Here we go. Now hit graph again. Oh, there we go. Mountains. Now, this is going to show more than one period. Now, look at what it's asking you to show. Okay, so you need to write here just see example 5 above. Don't you pack up. I hear you packing up. Your brains are packed up. Now, you have to find the max and minimum points only between negative 2 pi and positive 2 pi. So you have to go 2 full periods. How do you find max and min points? What menu in your calculator? Calc 0, right? Or, well, that's the menu. But then you go to max and min points, right? And then how do you find the y-intercepts? What's the easiest way? Go to your table. Very good. Very good, Kayla. Go to your table and plug in 0 for x. And you'll immediately get your y-intercepts.
I'm seriously just yelling at things in an attempt to just stay focused.
And look, it was right. So the max and min are on the notes online. I'd like you to go online and check out the notes, and I want you to do this one yourself. Okay, see if you can do it. We'll talk about all of your homework on Monday. You have a lovely weekend. Oh, yeah.